everyone. I am Assistant Professor Urmi Shah from ICT Department of LJ Institute of Engineering and Technology. So today we will be starting with our new chapter, that is Data Networks, unit number 5 in Telecommunication Engineering subject. So let's move ahead with the topics that we are going to cover in this session. Basically, I am going to cover the topics, that is data networks, data transmission in PSTN, that is public switch telephone networks. So these are the topics that I will be covering in this session. Let's start or begin with the first topic. So this data network topic is already familiar to all of you, as you all have studied it in Data Communication Network subject, that is DCN subject. But still, we'll move ahead with this topic, that is data networks can be classified according to their geographical coverage. Based on the coverage, we have three different types of network, that is LAN, MAN and WAN. LAN is local area network, MAN is Metropolitan Area Network, WAN is Wide Area Network. Based on the connectivity and the reachability of the user, the data networks are classified in three different types: LAN, MAN and WAN. Local area network are limited to certain distance. Metropolitan area are limited to certain geographical area like a city or a country, but wide area network is for long place all over the country. That is, these networks are based on the distance and the geographical coverage of our data. The first type of network is LAN. LANs are confined to a single building or a group of buildings within an organization, that is local area network. Commonly used transmission media in local area network are twisted pair cable, coaxial cable and optical fibers. So these are the widely used transmission media in local area network. Moving ahead, the next data network is Metropolitan Area Network. MEN are slightly used for wider geographical area compared to LAN. MANs are used to interconnect computer within metropolitan city. Communication medias are shielded lines, optical fibers and radio links. So these are the medias which are widely using metropolitan area network. Broadband capabilities provide data, voice and video transmission, that is a part of multimedia network which is included in MEN network. Synchronous optical networks like SONET is also designed using metropolitan area, which is operated at really high speed. So these are the features offered by metropolitan area network. Moving ahead, nextly, the other different types of wide area network is allocated for intercity, intercountry and intercontinental networks. So basically WAN covers intercity, intercountry, intercontinental, all the geographical coverage is included in wide area network. Communication medias are fiber optic cables or radio links according to transmission facilities. Wide area network uses lots of facilities, from which the first type is terrestrial data network. TDN is widely used for optical fiber communication. The other is satellite based data network. SBDN is used in geosynchronous satellite, which is used for space applications. So these are the widely used area network, that is wide area network, and it is used most widely in terms of all the three different data networks, that is LAN, MAN and WAN. Most widely uses wide area network. Even it is used in military, space application and for our safety applications also. So basically, this has been the trend of interconnection at global level in data network, that the network goes like this. On mediocre level, we have LAN network, that is local area network. The above level is MAN, that is Metropolitan Area Network. And at the end, which covers all the most of the geographical coverage of our country, of our Earth planet, that is wide area network. So LAN, MAN and WAN is having the different stages of data network. These are the three basic data networks in telecommunication. The data transmission now is going to be happen using public switch telephone network. PSTN are used for data transmission. How this process begins and how it is done, let's understand that. PSTNs and EPABX with suitable interfaces can be used for voice and data transmission. The maximum data rate for LAN and MAN over PSTN is 64 kbps. The data rate for ISDN can be varied from 1.544 to 2.08 Mbps. The analog signals are converted into digital signals for transmission over PSTN network, and vice versa is also possible at the receiving end, that digital has to be converted to analog data to retrieve the original data. So this is the task which is happening at data transmission in PSTN. Now moving further, a device called modulator, demodulator or modem. These are the three devices: modulator, demodulator and modem. These are used for data conversion. A data communication network using PSTN and modems is half duplex or full duplex. Now half duplex means it is having only at a time one communication way. Either you can send from sender to receiver or you can transmit from receiver to the transmitter side. So that is only a one-way communication, which we call as half duplex, while full duplex means simultaneously you can have both side communication from transmitter to receiver or from receiver to transmitter simultaneously. You don't have to wait for the transmitter to first transmit and then the receiver to again transmit or acknowledge it to the transmitter. Modems are driven by communication software that runs at user terminal or computer. So these are the very basic features and basic terminologies for data transmission in public switch telephone network. This is the overall diagram of data transmission in PSTN. In between there is a PSTN network, that is public switching telephone network, which is a 4-wire line network, and there is a dial unit from where different calls are dialed up, which is connected via a 2-wire line. A 2-wire line is going to handle the data traffic, and then we have the modem and computer networks. The modem is also followed by the terminal, data terminal, which has to be carry the data from one terminal to another terminal. So basically this is whole data transmission path or data transmission network via public switch telephone network, comprising of computer, modem, 2-wire, 4-wire, telephone line, public switch telephone network. So these are the different components of PSTN data transmission. Moving further, nextly, if I want to calculate the data rate in PSTN, that is public switch telephone network, how much data can be transmitted at a time, then it can be calculated using this formula, that is A voice channel in PSTN has bandwidth of 3.1 kHz. According to Nyquist criteria or Nyquist theorem applied for noiseless channels, the maximum data rate for voice channel is given by this formula, that is R is equal to 2 into capital H log V to the base 2 bps, that is bits per second. Now what is R over here? R is the maximum data rate for the channel. What is capital H over here? It is the bandwidth of the entire channel. And what is V? V is the number of discrete levels in the signal. So these are the three parameters which are involved in calculation of maximum data rate. Moving ahead, the examples for calculating the data rate are over here. If you have a 3 kHz ideal voice channel of PSTN and binary signal value V is equal to 2. How we will calculate the maximum data that can be transmitted through the channel? So the formula for data transmission is R is equal to 2 into H log V to the base 2 and the unit is bits per second. R is the maximum data rate, H is the bandwidth of channel and V is the number of discrete level. So let's apply the same formula in this question. So the bandwidth over here is 3 kHz. V, that is the number of discrete levels, are given 2 over here, and R is equal to 2 into 3 kHz. So it is 3000 Hz. 2 into 3000, it will be 6000 bits per second. 6000 bits per second can be transmitted via this communication channel. So that is the maximum data rate that can be transmitted from one end to another end. In a noiseless channel, the effective bit rate may be increased by increasing number of levels used to represent the signal. The maximum rate of signal transitions that can be supported by a channel is known as baud rate or symbol rate. Baud rate and symbol rate is the maximum number of symbols or signal that can be transmitted via a communication channel, that is baud rate and symbol rate. Now in this section we have studied it about what is data networks, what are the three different types of data network, that is LAN, MEN and WAN. LAN stands for local area network, MEN stands for metropolitan area network and WAN stands for wide area network. These are the references for the topics that we have covered today. Further, we have today learnt about what is a public switch telephone network. In public switch telephone network, how data can be transmitted. Then we saw the formulae regarding maximum data rate transmission. R is equal to 2H log V to the base 2. That is the bits per second that can be transmitted via a communication channel or PSTN channel. So that is what we have seen today. You can refer any of these references for the topics that we have covered. Nextly, in the next session, we will be continuing with the further topics of this, that is data networks, unit number 5 of telecommunication engineering. This is the second last unit of our subject. After this, only one unit is left, that is signaling techniques, that we will be seeing soon. And the applications of LAN, MEN, WAN, where they are used, what is data communication architecture, why the PSTN data transmission is not enough, that we will be seeing in the upcoming next session. For this, thank you very much for watching this session. In the upcoming session, we will move ahead with the further topics. Thank you for watching the video. Thank you.